Good day to all. Let's proceed to the other example. So we have two more examples for the section of shortcut method. So example 4.2, still we'll be using the SCWU as the shortcut model. So the details of this example, you may refer to monograph chapter 3. There's a file name called, this 006. For your information. So in this example, we are having a case of a mixture of N-butane and cis-2-butane. Okay, and we would like to design a column to recover 99% of N-butane and also 1% of cis-2-butane in the distillate product. What we need to do is the information given here is the property method is Bing Robinson, and feed information given the vapor fractions is 0.5, pressure is 1 bar, and the feed flow rate is 50 kilomole per hour for each N-butane and also cis-2-butane. So what we need to do for the column setting is reflux ratio. We have to put it, I'll put a gas of 2. Condenser pressure is 1 bar, so as the reboiler pressure. Light key recovery. So in this case, the light key information is given. Light key is N-butane, and the light key recovery is 99%, and the heavy key is butane, and the heavy key recovery is 0.01, okay, meaning 1% in the distillate. So if you follow the procedure as given in example 4.1, then the simulation results are generated with error. Okay. So this is the error message that you get, results available with error. When you are getting the results with error, then you have to analyze whether the results are still valid or not for you to use it further. Okay. If you click the control panel, then you are getting a message saying that the specified reflux ratio, which is 2, we have guessed the reflux ratio of 2, is less than the minimum reflux ratio, which is about 13.09, 13.09. Okay. Then it is saying that 2 times minimum used to calculate number of stages. So in this case, the DSTWU, the software, has actually taken the corrective action and calculate the actual reflux ratio based on the minimum reflux ratio. Okay. Meaning that the results that are generated through this simulation are still valid because the software or the model, the SCWU model, has taken the corrective action to produce the results accordingly. Okay. So these are the results generated. So we can still use this result to proceed further in the rigorous method later on. That means these results are valid despite the errors given. So we move to example 4.3, another mixture of ethanol and also water. And it is known that ethanol and water mixture will form azeotrope. Okay. So let's try to simulate this case. So in example 4.3, we would like to design a column to recover 99% of ethanol and 1% of water in the distillate product. So obviously ethanol is the light key and water is the heavy key. So property method that is recommended is unique RK, and the feed information is feed flow rate of ethanol and water 50 kilomole per hour each. Pressure is 1 bar and the vapor pressure is, the vapor fraction is 0.5. In terms of column information, pressure is 1 bar and the column is actually equipped with total condenser, and we have to put the initial gas for reflux ratio of 2. Before we try to put in the details of the column and also feed, of course, as usual, you create a blank simulation, then you put all the put in all the components that involved in the process. Then you have to select the method before you generate the properties for your component. So when you select the methods over here, the method given is Uniquet RK. So you have to first change the method filter here to all. Instead of using common, you have to change it to all. Then only you can find Uniquet RK as one of the method, right? So once you have that, you just choose it accordingly and run the process to generate the properties for your component. Okay. So if you follow the other procedure as given in example 4.1, then just key in the feed information, column information. The simulation results are generated. Again, this is also with error. Okay. So as I mentioned to you, whenever you have generated results with error, then you have to analyze the validity of your results. Okay. So as usual, you have to click the control panel, then this message will actually turn up. From here, you troubleshoot and you verify the validity of your results. So it is saying that calculated minimum number of stages is less than 0. That means the number of stages is in negative. It's a negative value. And this usually results when it is not easy to separate. It is too easy to separate the light and heavy key components. Okay? So if this is a case, meaning it is actually an indication of the azeotrope formation. So whenever we have azeotrope, the assumption of constant relative volatility is now. So this is one of the assumptions that we make when we use a shortcut model, the STWU. This is no longer valid with the presence of azeotrope, meaning the results are also invalid. Okay? So in this case, we cannot proceed to use the results generated. And the STWU is not a good model for you to simulate a distillation process when you have a feed of mixture that will form azeotrope, right? So bear this in mind. You have to use other model like red flag, a more rigorous model to solve the problem, which is with azeotrope formation. So we have finished all the examples, the 3 examples. So there are some take-home messages here, meaning this is a conclusion that you have to remember. So the STW block implements the following methods. So V method, Underwood method, and also Gilliland method, right? So the model is based on the assumption of constant relative volatilities and constant molar overflow, and the results generated are just a rough estimation. So it is always with the output from the shortcut method simulation. We are using this as an input in a more rigorous simulation using red flag to produce a more accurate simulation result for distillation column, right? The STW block should not be used for mixture that is significantly deviate from the above two assumption. For example, the azeotrope just now. So when you have a mixture with azeotrope formation, you have to use other rigorous model instead of using shortcut model with the assumption of constant relative volatilities. So the last message here is if you are getting simulation results with error, then you have to analyze the validity of the results based on the error message that you get from the simulation. Okay, so if it's not if something that you can't ignore, you just can't take the results from the simulation, like the case of azeotrope formation. So what is the next for you? So for online learning, we would encourage that after every online learning, we will have a quiz for you to evaluate how good you have learned through the online learning. Okay, so before you perform the online quiz 3 on shortcut method by 3rd of June, before 11:59 p.m., you can do your own revision by going through the video, and also you can go through the demonstration video that I have made for you on the simulation steps using Xpen Plus. So with this, I would like to thank all of you, and I hope you enjoyed learning. Thank you very much.